Hey guys, so here we have a parallel circuit and we can go ahead and map out our voltage. We know that a battery, this is the symbol for a battery, this is going to be the positive end because it's the long end, this is the negative end. And here we have another battery, the long end is the positive end, the short end is the negative. And we always, at the end of our circuit, we have 0 volts. So we can go ahead and map this out and go backwards. We know until we hit something we're going to have 0 volts. So we have 0 volts all along here until we run into these different resistors. Alright, and then we have 0 volts, but we go through a 9-volt battery. So we have 9 volts here, and we go through another 9-volt battery. So we have 18 volts here. And we will continue to have 18 volts all the way across until we hit something. Alright, so this is why a parallel circuit, when you have different resistors, they have the same voltage going through them because you have 18 volts going in and with every single one, and you have 0 volts going out. So they all have a voltage drop of 18 volts. Alright, so our total voltage is 18 volts for this problem, and the total resistance must be less than what? Well, in a parallel circuit, the total resistance can never be more than the smallest resistor. So it must be less than 4 ohms. Alright, now which branch will have the most current? Well, current is equal to voltage over resistance. So the smaller the resistance, because our voltage is not changing, it's 18. The smaller the resistance, the greater the current. Therefore, since 4 ohms is the smallest resistor, it will have the most current. So this is 4 ohms. Right? And it says calculate the total resistance. So first things first, we need to go ahead and figure out how much resistance we are using, or how much current we're using across these resistors. So to find current, it's I equals V over R. So our voltage is 18 and this resistance is 6. So we end up with 3 amps on this one, and we have the same voltage for this second resistor, but now we have 4. So 18 divided by 4 is 2.5. Let's go ahead and double check that. So 18 divided by 4, and we get 4.5. So we have 4.5 amps going down this path, and then 18 divided by a 12 ohm resistor, and that is going to give us 1.5. Alright, so 1.5 amps along this guy. Alright, so you take it all the way out, we have a 1.5 amp current coming here, and then these are splits, where the wire splits. Alright, and these are joins, right here and here. So we have 1.5 amps, and that current runs into this 4.5 amp current, so 4.5 plus 1.5 will give us our combined current through the wire, which is 6. So from here to here, we actually have 6 amps moving this way around the circuit. But we run into another 3 amp current, so we add the 6 amps and the 3 amps and get a total of a 9 amp current. So our total voltage, let's recap, is 18 volts, and our total current is 9 amps, because we've added all of our currents up. So we can actually find the total resistance if I is V over R. Then our total resistance, if we manipulate that equation, R equals V over I. So we know that our total voltage is 18 and our total current is 9, and we would divide that and get 2 ohms. Alright, also we talked about finding the current with this formula, not the current, the resistance, and that's 1 over 1 over R1 plus 1 over R2 plus 1 over R3, or however many resistors you have, and we do happen to have 3. So what we're going to do is put 1 over, and then you're going to start your parentheses, 1 over 6 plus 1 over 4 plus 1 over 12, and we should get the same thing. We should get 2 ohms. And we do. So we know that this total resistance for the parallel circuit is 2 ohms.